Elasticsearch. Before deep diving into it, let's ask some questions and understand why do we really need it. Have you ever searched log across hundreds of servers or searched products on an e-commerce site and got results instantly? That's exactly the kind of problem Elasticsearch was built to solve. People use Elasticsearch for multiple things. One very common use case is log and event analytics. For example, your application, your Kubernetes log, or any other application access logs, everything flows into Elasticsearch and we can search it like Google. Another big use case is application performance monitoring or APM. Here, instead of just logs, you are indexing traces, metrics, response time, error rates, and database latency as well. And yes, Elasticsearch is also used for full text search, searching products, blogs, documents, or usernames, or even a slight keyword like car within tons of blocks. Some people use it as a kind of NoSQL data store, not as a replacement for databases like PostgreSQL or MongoDB, but for read-heavy and search-heavy workloads. So why not just use a traditional database? That brings us to the key difference. Inverted index. Imagine you have two documents. Document 1 says DevOps use Elasticsearch, and document 2 says Elasticsearch is fast. In a traditional database, you would store documents first and then search inside them, but Elasticsearch flips this idea. It stores data like this. The word DevOps points to document 1. The word Elasticsearch points to document 1 and 2. The word fast points to document 2. So instead, document is pointing to words, it stores words pointing to the documents and their IDs. This is called an inverted index, and this is why full text search in Elasticsearch is insanely fast. It doesn't scan documents one by one, it jumps directly to the relevant documents. The trade-off: writes are slightly heavier and the storage usage is heavier, but searches are extremely fast. Now, once the data is indexed, Elasticsearch still needs to know how to treat the data. That's where mappings come in. Mappings define how your documents and fields are stored and indexed. You can think of them like schemas, but more flexible. Elasticsearch also supports dynamic mappings, where it automatically detects field types when data comes in. That's convenient for learning but risky in production, so we always define a mapping and then we store the data. Now let's talk about something that directly affects the search quality, and it's called analyzers. Analyzers define how text is processed before indexing and before searching. An analyzer is basically a pipeline. First, character filters clean the raw text. Then a tokenizer splits text into tokens. The token filters normalize these tokens, like lowering casing, removing stop words, or applying synonyms. Elasticsearch gives you built-in analyzers like standard, whitespace, keyword, language-specific analyzers, and multiple analyzers can be stacked. Now, one more thing that really improves search experience, and that is synonyms. Synonyms allow different words to be treated as equivalent. For example, if you search for car, it will also try to search for automobile and vehicle. If you search for K8s, it will also try to search for Kubernetes. Finally, a quick word on deployment. Elasticsearch can run in multiple ways. You can deploy it on virtual machines by running the binaries directly. You can deploy it on Kubernetes, or you can use managed services like AWS OpenSearch. Now, this is enough talking about Elasticsearch because I don't want to deep dive within it. I just wanted to give a brief idea about it, around it, that a DevOps engineer or a developer should be knowing. Further, we'll look into how the actual architecture is being followed, how we can deploy things and create indexes. If you found this video slightly informative, then please drop a like and subscribe if you haven't. Thank you, and I'll catch you in the next video.